The Defence Research and Development Organisation of India, known as DRDO, has been steadily advancing its Agni series of ballistic missiles over the past decade as Agni I through Agni VI. Each generation has pushed boundaries in range, payload, mobility, and precision. Now, in 2025, the next leap forward is rumored. The Agni VII, a three-stage, solid-fuel, mobile intercontinental ballistic missile currently under development. What could this missile bring to the table, and how might it shape strategic deterrence? Let's dive into the details of this emerging missile. Agni VII appears to build on the technological and structural foundations of Agni VI but with enhancements suited for the next generation of strategic weaponry. Sources describe it as a three-stage, solid-propellant ICBM with a nominal range of around 7,000 kilometers, capable of carrying a substantial payload estimated at about 2,000 kilograms. That payload margin could support multiple warheads, decoys, or advanced penetration systems. The missile's design seems optimized for road mobility, with a canisterized launch system mounted on an 8 transport erector launcher chassis similar to Agni V. This means it can be rapidly deployed and launched from hidden or remote locations, enhancing survivability and strategic flexibility. At the heart of Agni VII will be advanced guidance systems, most likely an inertial navigation system using ring laser gyroscopes combined with multi-GNSS satellite guidance, much like Agni V's navigational suite, which achieves a circular error probable (CEP) of under 10 meters. Expect DRDO to further refine this with micro-inertial backup, onboard computing, and perhaps artificial intelligence-inspired trajectory optimization. What sets Agni VII apart is speculation around enhanced multi-warhead capabilities. Agni VI plans to carry up to 10 MIRVs over 10,000 kilometers. Agni VII may continue this MIRV trend, possibly combining multiple warheads with maneuverable re-entry vehicles, MARVs, or hypersonic penetration aids, heat-tolerant, agile systems capable of evading missile defenses. This is bolstered by DRDO's recent testing of advanced canister launchers weighing around 70 tons, possibly intended for a missile heavier than Agni VI, likely Agni VII or its variant. These canisters offer sealed storage, rapid launch, and improved protection of delicate missile components. The increased weight capacity opens the door to larger fuel loads, broader payload mix, or thermal shielding for re-entry systems. Agni VII would also likely feature hardened warheads, bunker buster capabilities, or deep strike payloads, with Agni V's enhanced version aiming for a 7,500 kilograms warhead to penetrate 100 meters of reinforced concrete. One can imagine Agni VII carrying on that legacy in a more refined form, perhaps with lighter, smart penetrators or binary-shaped warheads. From a strategic standpoint, Agni VII's potential range of around 7,000 kilometers places all of China, Russia's far eastern territories, Europe, and beyond within reach. If it surpasses that to, say, 10,000 MED would join the ranks of true global strike ICBMs. That aligns with India's intent to field a credible second strike capability, ensure deterrence, and maintain strategic autonomy. Comparing Agni VII with Pakistan's HAT-7/BABR cruise missile, also referred to as HAT VII, however, reveals architectural differences. Pakistan's BABR is a terrain-hugging, subsonic cruise missile with the range up to 700 kilometers, optimized for tactical deterrence within regional theaters. Agni VII is an entirely different concept, a strategic, long-range ballistic system. The two share nomenclature but not mission profile or capability. In global context, Agni VII would compete conceptually with other advanced strategic missile systems. Russia's Vanguard hypersonic glide vehicle can hit Mach 20+ and maneuver during re-entry. The U.S. attempted Agni 183 ARRW hypersonic missile, but that program has been largely cancelled. Instead, the world's predominant MIRV solid-fuel ICBMs are in the US, Russia, and China. Agni VII may finally place India in that group, albeit perhaps with unique Indian-design MaRV units. Technologically, DRDO would need breakthroughs in composite propellant, modular rocket motors, miniaturized warheads, heat-resistant re-entry vehicles, and advanced inertial computing, all areas they have previously developed, with each iteration beginning at Agni III and progressing through Agni VI. The challenge now is integrating them at scale, ensuring reliability and safety in longer-range missions. Testing will likely begin within a year or two, maybe around 2026. DRDO typically undertakes lofted trajectory trials first to validate propulsion, structural integrity, and re-entry thermal protection without full-range impact. Once milestones are cleared, standard full-range tests will follow, culminating in user readiness and induction. Deployment could take the form of road mobile canister units stationed in central India, moved around to hide launch sites and maintain credible deterrence survivability. The canister system supports vertical launch and reduces pre-launch prep time. Strategic rocket forces will coordinate with other assets, including missile subs, Agni VI compatible, and nuclear command frameworks. Deterrence implications are significant. Agni VII would strengthen India's nuclear triad and serve as a robust second strike pillar. It shifts strategic balance by extending the reach to cover global adversaries, complicating planning for potential aggression. MIRV capability allows multiple targets from a single missile. Decoys, penetration aids, and maneuverability make missile defense much harder to deploy effectively. There are international reactions to consider. Countries like the US and China may view an Indian ICBM as a shift in nuclear posture. However, India has a declared doctrine of no first use and credible minimum deterrence. Agni VII would likely be presented as complementing that posture via a delayed response capability, not an arsenal expansion. Still, strategic allies and rival states will watch closely, adjust tracking, and may push for diplomatic dialogue around these developments. Yet the program faces challenges. Technical development at this scale is complex. Budgetary limits, political approval, and nuclear command system upgrades will shape timelines. Missile defense counters will spur development of stealth, decoys, MaRV, and possibly even hypersonic glide sections to higher cost and complexity. Export control frameworks and strategic stability dialogues may arise as part of the diplomatic landscape. Assuming successful development and induction by around 2030, Agni VII would be the crown jewel of India's missile force at long range, multiple warhead, mobile, quick-reacting, and connected to nuclear command. It would complete the multi-layered deterrence posture alongside Agni V, Agni VI, sea and land-based cruise missiles like MiRV, and tactical SRBMs like Prithvi and Agni P. So what's next? In the coming months, watch for procurement notices for heavy TELs or canisters, partner contracts for composite motors or navigation systems, or open-source satellite images of secret test pads. Defense analysts will follow mention of Agni VII in parliament debates, budget sessions, and think tank studies. Ultimately, only a successful flight test will confirm its arrival. To sum up, Agni VII is poised to be India's next-generation strategic missile. It builds on the Agni line's legacy of solid fuel, mobility, accuracy, and multiple warheads. The hardware and development of three-stage boosters, canister technology, and guidance upgrades all point toward an ICBM capable of striking deep strategic targets. The strategic payoff is clear: stronger nuclear deterrence, credible reach, and modernization of India's missile forces, while fitting within its declared doctrine. The big questions now are timing, testing success, and eventual deployment. Stay tuned if all goes as expected. Agni VII could be publicly demonstrated by the end of the decade. For now, its development is one of the most closely watched missile programs in Asia, with ramifications both regional and global.